So today we'll look into topic 3, mole concept, where in mole concept we have 3 subtopics. And for this video, we'll focus on topic 3.1, where we will look into what is Avogadro number and the relationship between Avogadro numbers with molar mass and molar volume. So, what is actually 1 mole? 1 mole is defined as the amount of substance that contains as many particles as the number of atoms in exactly 12 grams of carbon-12, which is 6.02 times 10 to the power of 23 particles. And the 6.02 times 10 to the power of 23 will be called as Avogadro constant. 6.02 times 10 to the power of 23 is this much. 1 mole in chemistry, it works like 1 pair or 1 dozen in your daily life. If 1 pair is equals to 2 pieces, we know that if I have 1 pair of shoes, means I have 2 shoes. If I have 1 pair of gloves, means I have 2 gloves. 1 dozen is equals to 12 pieces. When I say I have 1 dozen of eggs, means I have 12 eggs. If I have 1 dozen of apples, I have 12 apples. How about 1 mole? How much is actually 1 mole? If I say I have 1 mole of apple, I am actually having 6.02 times 10 to the power of 23 apples. If I say I have 1 mole of eggs, means I have 6.02 times 10 to the power of 23 eggs. And 1 mole works exactly like 1 pair or 1 dozen. It's a bigger value. So don't be scared with the word mole, alright? So when I apply 1 mole in chemistry, 1 mole in chemistry represents how many particles? It represents 6.02 times 10 to the power of 23 particles. 1 mole to the mass of atom or molecule is actually equal to the relative atomic mass or the relative molecular mass. Means if I have 1 mole of hydrogen gas is actually equals to 2 grams because 2 hydrogen. If I have 1 mole of oxygen gas, then it's actually equal to 32 grams. How about volume of the gas at STP and RTP? What is STP stand for? STP stand for standard temperature and pressure. That is what STP stand for. And standard temperature pressure means the temperature is 0 degrees Celsius and 1 atm. How about RTP? RTP means room temperature and pressure. So room temperature and pressure means 25 degrees Celsius and 1 atm of the temperature and pressure. So if I have 1 mole of gas at STP, it represents I have 22.4 liter of the gas. If RTP means 24 liter of the gas. That means if I have 1 mole of hydrogen gas at STP means I have 22.4 liter. The same gas I put into RTP. So I have another 1 mole of hydrogen gas, but I put it at 25 degrees Celsius. Means I have 24 liter. The different volume is due to the different temperature. 0 degrees Celsius, 25 degrees Celsius. So let's look into some example. I have 1 mole of helium. So 1 mole of helium is actually equals to 6.02 times 10 to the power of 23 helium atoms. And the mass of the helium is the relative atomic mass of helium, which is 4 grams. So when I have 1 mole of helium, it's actually 4 grams of helium. The volume of gas at STP, when I have 1 mole of helium gas at STP, means I have 22.4 liter. And when I have 1 mole of gas at RTP, means I have 24 liter. Another example that I have on the screen is 1 mole of carbon dioxide. So when I have 1 mole of carbon dioxide, how many particles I'm having? 1 mole again is equals to 6.02 times 10 to the power of 23 carbon dioxide molecule. How about mass? 1 mole of carbon dioxide is equals to the relative molecular mass, and the relative molecular mass of carbon dioxide is the mass of carbon plus the mass of oxygen, where if I have 1 mole of carbon dioxide gas, means I have 44 grams of carbon dioxide. So what happens if I have 1 mole of carbon dioxide at STP? Again, at the STP means I will have 22.4 liter. Remember, STP means 0 degrees Celsius, 1 atm. So, at RTP means 25 degrees Celsius and 1 atm. And when I have 1 mole of carbon dioxide, I put it into 25 degrees Celsius and 1 atm, I will have 24 liter. Is that clear? So let's look into others conversion. When I have mole and I want to convert to number of particles, you'll be using Avogadro constant. From mole to number of particles, we will times Avogadro constant, which is 6.02 times 10 to the power of 23. If I have number of particles to number of mole, it's the vice versa, means we will divide with the Avogadro constant. We have 3 types of particles. The particles that we can have is atom, molecule, or ion. When I say 1 mole of atom, that represents 6.02 times 10 to the power of 23 atoms. And when I say 1 mole of molecule, that is still 6.02 times 10 to the power of 23 molecules. When I say 1 mole of ion, that means 6.02 times 10 to the power of 23 ions. So 1 mole is forever equals to 6.02 times 10 to the power of 23. How about I don't have 1 mole? If I only have 0.5 mole of potassium, how many potassium do I have? So we can see number of mole is given and I want to change to number of particles. So we times Avogadro constant. And before I start calculate this, it's better for you to take out your pen, your paper and your calculator. It's easier for you to understand by doing it together. So I have 0.5 mole of potassium and I want to change it into particles. Therefore, I times with the Avogadro constant again. So I times 6.02 times 10 to the power of 23. Press your calculator correctly. Make sure you have the bracket in your calculator. And when you solve it, you realize that 0.5 mole of potassium is equals to 3.01 times 10 to the power of 23 potassium atom. The next example that we have is the question gave you the number of molecule of nitrogen gas but asking for number of mole. So how can we convert the number of molecule to number of mole? Number of molecule is the number of particles, and changing to the mole means we divide with the Avogadro constant. So we will be taking 1.338 times 10 to the power of 23 molecule of nitrogen gas divide with 6.02 times 10 to the power of 23 Avogadro constant, and that will give rise to 0.2222 mole of nitrogen gas. I hope you are pressing the calculator and doing it together with me. The second conversion that we will look into is the number of mole to mass. So the conversion definitely involves relative atomic mass and relative molecular mass. Changing from the mole to the mass, we will times with the relative atomic mass for atom or the relative molecular mass for molecule. Vice versa of it, changing from mass to the mole, we will divide with the relative atomic mass or relative molecular mass. Looking into more example, I have 1 mole of sodium. 1 mole of sodium equals to how many gram? 1 mole of sodium is actually equal to 23 gram, the relative atomic mass of sodium. 1 mole of oxygen gas means how many gram? Is 32 gram, the relative molecular mass of oxygen gas. 1 mole of sodium chloride is equals to the mass of sodium plus mass of chloride, which is 23 plus 35.5. So 1 mole of sodium will give rise to 58.5 gram. 1 mole of the atom or 1 mole of the molecule will be equal to the relative atomic mass of the atom or the relative molecular mass of the molecule. But what happens if we don't have 1 mole? If in the question, you only have 0.33 mole of sodium. So, how do we know how many gram is there? So what do? We will use the 0.33 mole and times with the relative atomic mass of sodium, which is 23 gram. So press your calculator. 0.33 times 23 equals to 7.59 gram. Vice versa, if the question gives you in the form of mass, the question gives you 10 gram of oxygen gas, but the question asking for number of mole. How many mole is that? We will take the 10 gram of oxygen gas, divide with the relative molecular mass of oxygen, which is 32 gram. So 10 divided by 32. When you press your calculator, you realize that is 0.3125 moles. Simple, isn't it? So we just need to make sure that the relative atomic mass and the relative molecular mass is correct. Make sure you know when is to times and when to divide. The next conversion that we have is number of mole changing to volume gas at standard temperature and pressure. So remember, STP stands for standard temperature and pressure. And the standard temperature and pressure represent 0 degrees Celsius and also 1 atm. Let's look into how to convert mole and the volume. We'll be using the molar volume. We know that 1 mole of any gas at STP is equals to 22.4 liter. So 22.4 liter is what we call molar volume. And if the question gives you a number of mole of gas and changing to the volume is times the molar volume. Vice versa, if I have the volume of gas at STP and I want to change to number of mole, we divide the molar volume. Make sure you identify whether they are at RTP or STP. Some example over here. If I have 1 mole of helium gas is equals to 22.4 liter. If I have 1 mole of oxygen gas at STP, it will be also equal to 22.4 liter. If I have 1 mole of carbon dioxide gas at STP, it will also equal to 22.4 liter. it doesn't matter what gas you are having. What important is 0 degrees Celsius, 1 atm is the condition. So as long as you are in this condition, 1 mole of any gas will equals to 22.4 liter. And what happens if you don't have 1 mole? If the question say you only have 0.45 mole of helium gas, how many liter is that equal to? So you'll be taking the 0.45 mole of helium times or divide times with the molar volume 22.4 liter. Press your calculator correctly and the answer is 10.08 liter. Vice versa of it, what happened when the volume is given at STP but asking for number of mole? So what do? We divide with the molar volume. So we'll be taking the 15 liter and divide with the 22.4 liter. And when you press your calculator correctly, that is equals to 0.6696 mole. Simple? Very simple. The last conversion that we have is changing the number of mole to volume gas at RTP. So RTP stands for room temperature and pressure. So room temperature and pressure equals to 25 degrees Celsius and pressure remain at 1 atm. What makes it different is the value. 1 mole is equals to 24 liter. So changing from the mole to volume is times. Vice versa, from the volume to mole, we divide. So the 24 liter is what we call molar volume at RTP, or we call it just room temperature. Remember that. So let's look at the comparison with the STP by using the exact examples. If I have at the RTP 25 degrees Celsius 1 atm, 1 mole of any gas will equals to 24 liter. Whether it's a helium gas or oxygen gas, it will still be 24 liter. Carbon dioxide gas will also be 24 liter. 1 mole of any gas at RTP will still equals to 24 liter. And what happens when you don't have 1 mole? You only have 0.4 mole of helium at RTP. So how do you change the number of mole to volume? You times or you divide. If you times, how many do you times? 22.4 or 24? Since it's a RTP, therefore we are using 24 liter. And since we are having number of mole, we need to change to volume. Therefore, we will times. The solution will look like this. 0.45 mole of helium will times with 24 liter. And when you press your calculator correctly, that is equals to 10.80 liter. Vice versa, when you have the volume of gas given at RTP, but the question asking for number of moles. So what do you do to change the volume to number of mole? You will be dividing the volume with the molar volume, 24.0 liter. Why 24 liter? Because it's at RTP. So again, pick up your calculator and start working it out. 15 divide 24, that is 0.625 mole. And we are coming to the end of it, and that is mole concept. Very simple. Very simple conversion, very simple concept. Don't make yourself confused just because of the word mole. So we have 4 conversion. We change the mole to particles. We can change the mole to mass. We can change the mole to volume. And in volume, we can have 2 different conditions. SDP and RTP. So make sure you can differentiate them. They are very simple. Have a good day and I'll see you.